and semantic modeling of risk in the semiconductor manufacturing. The semiconductor manufacturing is one of the most complex industry, with more than 700 steps, the presence of reentrant flows, and a cycle time of 2 months. There is a necessity to secure the production. In such complex environment, several levels and types of control are set, as it is not possible to measure all products. There is a sampling performed to select which product will be measured. Each measurement does not only give a direct explicit information about the product being measured, but also an indirect and implicit information about the equipment that processed that product. This observation is at the core of a well-known concept in the semiconductor manufacturing, the wafer at risk. The proposed ontology aims at making explicit this kind of implicit information. We propose a first use case for this ontology with a concrete example of the wafer at risk concept. Imagine a scenario involving 3 processing steps, labeled P1, P2, and P3, along with 1 measurement step, M1, and 2 wafers, 1 orange and 1 green. First, the orange wafer undergoes processing through P1, P2, and P3, bypassing any measurement step. Following this, the green wafer is processed through P1 and P2, but, unlike the orange wafer, it undergoes a measurement at step M1. Here's where the concept of wafer at risk becomes crucial. If a defect is identified in the green wafer during the measurement at M1, we infer that the orange wafer, which was processed earlier on the same equipment, might also be at risk of having similar defects. This is because the defect was detected only after the orange wafer had already been processed. The critical takeaway here is the flow of information. When a problem is detected in one wafer, it can have implications for others processed before it, especially if they share equipment. Our aim is to effectively represent this flow in our ontology. Modeling the risk is a challenging task, as a product can be at risk at one time T can be free of risk at another time. To be able to represent that, we adopt an existing solution where gain and loss of attribute are treated as event to which the object, attribute, and time are related via binary relations. In order to show the capability of the ontology, we also define key concepts aligned with the digital reference, and other concepts necessary to define the semiconductor risk. The different concepts of the ontology are instantiated to represent a synthetic fab with the necessary relations between them. We instantiate a variation of the earlier presented use case, comprising 2 processing steps, 1 measurement step, and 2 wafers. By applying a tool such as Protégé to our use case, we observe that our ontology successfully infers that a tool is at risk if it has processed a wafer exhibiting defects. We have developed a tool, based on SparNatural, to facilitate interaction with our ontology. This tool not only allows for visual exploration and navigation of the knowledge base, but also enables users to execute previously saved queries, construct new queries visually based on the concepts in the ontology, and run and display the results of these queries. In this demonstration, we show how to build a query. Initially, we see the concepts available in the tool to create a request. To retrieve all the equipments located in a specific workshop, we click on the equipment concept. If we are interested in one specific workshop, we can then click on the workshop concept that will display all the workshop in our knowledge base. We select the dry etch workshop, and now our query is ready. After running it, the expected result, the etching equipment, is returned and displayed. In the same way, we can remove the dry etch workshop condition and request all equipment in any workshop. Again, we can see that this query returned all equipments in all workshops. Now let's go back to our wafer at risk use case. Here we request all products that are at risk. As of now, we only model one type of risk named risk A, which can be interpreted as a contamination risk here. Running this query shows the wafer that was at risk in our example. In summary, our project has effectively proposed a semantic model that addresses operational risks within semiconductor manufacturing, providing practical business use cases. Looking ahead, some improvement include refining the ontology, rigorously applying and testing our approach with real-world industrial data, and integrating various types of risk-related information to achieve a comprehensive, unified view to significantly advance risk management practices in the semiconductor industry.